Hello students, Ms. Slyman here with the first part of 9.6, and this is the binomial theorem. So a plus b is a binomial because we've got two terms, and a plus b to the n power is a power of a binomial. So the first thing that I'd like you to do is I'd like you to expand all of these 5 items. So I'll start with you. The first one, a plus b a to the 0 is 1, anything to the 0 is 1, a plus b squared, a squared plus b squared plus, a squared plus 2ab plus b squared. And then I would like you to expand these two as well. And then look only at the coefficients. So if we look only at the coefficients so far, well, coefficient of 1, 1 is a coefficient. Here my coefficients are 1, 1. In this level, I have 1, 2, 1. So coefficient of 1, coefficient of 2, coefficient of 1. So keep going with these 2 rounds, and we're looking for a pattern called Pascal's triangle. So pause your video, do that. All right, so hopefully you notice some patterns here in the triangle. We've got along the outside diagonals, all we've got are 1s. The second number in tells us the power. So here there is no second number in, the power was 0. Here the second number in is 1, the power is 1. Second number is 2, we get a squared. And then all these other numbers form our coefficients. Obviously, we made the triangle with the coefficients. But we can always start with the initial term is being raised to our power. So let's look at the next one coming down. We know it's going to have a 1. Looking down this next diagonal, they're always going up by 1. So my next one is going to be 5. More specifically though, the next number in, this 3, this 6, well, that's coming from 2 plus 1 is 3, 1 plus 2 is 3. We've got 3 plus 3 made this 6. So now 4 and 6 is 10, 6 and 4 is 10, 4 and 1 is 5, and coming down the diagonal I have 1s. Notice with my powers, I've got a to the 4th, a to the 3rd, a squared, a, no a's, no b's, b, b squared, b cubed, b to the 4th. This tells me that with Pascal's triangle, I know that a plus b to the 5th is going to be a to the 5th plus, so 1a to the 5th, 5. Now the a goes down in power and b increases in power, plus 10, a to the 3rd b squared, plus 10, a squared b cubed, plus 5, ab to the 4th, plus b to the 5th. Notice for powers that I have exactly one middle term, so I know it's the middle term because my 2 powers are even. Then there's going to be a single number. But if I have to split the middle like I did here, so a to the 3rd b squared, a squared b to the 3rd, those have the same coefficients. And this is fine if I'm just going for a few rows, but let's say that I wanted the coefficients of a plus b to the 15th. Well, it would be a big pain to work out my whole triangle. So instead what I do is I use combinations. So I've got my formula n choose r. You remember this from the very beginning, hopefully. That's going to give us all our coefficients. So let's go back and test this with our power of 5. So if we say that n is equal to 5, and r is the term we're going to look at, so let's say we're looking at the 3rd term. It's going to be here. So we've got 5 factorial over 3 factorial times 2 factorial. Well, 5, 4 is going to cancel out the 3 factorial, 2 factorial, cancels with that, and I get 10. So my coefficient of the 3rd term is 10. Notice that's also my power, but I feel like I want my r term. So we start with 0. Yes, we're looking at the power of b actually. So when I found this 10 here, it was actually this term. So r is going to be your power of b. Yeah. So that's a key thing to notice, that r is my power of b. The power of a is going to be the n minus r. So really, it's these two things, but reversed. Power of b, power of a. All right, so I'm going to come back, and in the next video, we'll look at some examples.